So if you wanted to add lights to your car, say this is like a plow attachment, the circuit is extremely simple. In fact, you can connect it directly up to the battery and it'll light. But for safety reason, of course, you probably want to have a fuse interrupting the circuit so that in case you have wires external to the car, or a rabbit or a vermin, some kind of mouse comes in and chews your wires and it starts shorting. I mean, a battery can cause quite a spark, with cranking amps into the hundreds. So a fuse is almost a no-brainer. But choosing a fuse is not a no-brainer, and that's because you have to know how much current your system is going to pull under what normal conditions are, and then you want to put a fuse in that's a little bit higher, just a little higher than normal conditions, so that if something like a short circuit does happen, it'll pop the fuse. Initially, when I wired these lights up, I didn't know how much current they would draw, so I put a 10 amp fuse as just really a guess, and with both of them on, it popped the fuse. So I know it's pulling more than 10 amps, and it means it's time for me to test the lights, do some calculations, and get a real number. So like the goal would be to calculate or maybe measure, how much current this thing is going to draw. So, without actually hooking up any circuitry, one thing we could try is to measure the resistance across the bulbs. Now, this light actually has two bulbs, or there's two filaments inside of a single bulb, and they're hooked up in such a way that there's one pin is shared between two of the filaments, and then the other side of each filament goes to here and here. So there's actually like a high beam and a low beam, or a bright and a dim setup going. And we want to know how much current will the system draw, when both of them are on. Because if you're driving at night, you'll probably have all of the lights, as many as you can, turned on, and you don't want to pop a fuse because you actually turn both at the same time on. So what we could do is measure the resistance across one of the filaments. And let's see, let me get my meter into the right setting. So the theory behind measuring resistance, since resistance is defined as the opposition to the flow of current, if you know what your battery voltage is, you can take the battery voltage and divide it by the resistance. And let's see, the contacts are a little bit dirty, but I'll get there. All right. But yeah, I said if you take the battery voltage, divide by the resistance, that will tell you the current. So my meter is reading about 0.5, 0.6. So I labeled this one as 0.5 ohms, and the same test, we go to common to the other filament, and it's maybe a little higher, 0.6, 0.7, 0.8, 0.7. Okay, so I called it 0.6, maybe it's 0.7. So off of that rough calculation, 12 volts divided by half of an ohm is 24 amps. That sounds like a lot for a light bulb, and certainly it would be enough to pop the fuse. But there's actually something else at work here, and that's right now the filament is cold, and for a filament or a heater, or most types of actually I'd say any incandescent bulb and heaters and stuff like that, basically resistive components will increase their resistance as the temperature gets hotter. And the theory behind that is the particles in the metal start bouncing around more at higher temperatures, and the electrons have a harder time getting through because of all the buzz going on inside. At least that's how I think of it. So this is really 24 amps when cold, but as soon as you put voltage across it, those filaments are going to begin to heat up, and the resistance will increase, which will force the current to go down to something less than 24 amps. And so it would not really be right to say that this single that a single filament will pull 24 amps. I mean, come on, if you did that, you have 2 filaments per bulb, and you have a bulb on either side of the car. You're almost at 100 amps, and that would be absurd, and that's not and that would not be safe to put in a 100 amp fuse on this thing, because there's almost no point. Your 100 amp fuse, you're probably going to start a fire anyway. So we need to know how much current the bulbs will pull when they've already heated up to what their normal temperature is, that they've been running for a couple seconds, and then we can use that as the real value for the current. So we actually can't measure and calculate that one very well. Instead, we actually are going to do a direct measurement of current. So we're going to we're going to set up a circuit with a battery, and we're going to turn the light on, but then we're going to pass the current through the meter, and the meter will tell us how much current is flowing through the system. So this is a battery for jumping your car. It's a 12 volt battery, so it's the same pretty much conditions as what is in your car. And I just have these little alligator clips hooked up to the big ones just because I can work with them easier. And so what I'm gonna do is connect one, and I'm gonna take this off of this bubble wrap. I have it here to not damage the light, but I can set it on its side, I guess, like this. And I'm going to connect to the common pin the battery minus, or the battery ground, basically. And then the other one, the battery plus, goes to the meter, and then it'll go through the meter, and we can close the circuit to one of the bulbs by touching one of these pins. So we should get light. Oh, I gotta turn my battery on, and we'll get light. Okay, so one of these is a high beam, the other is a low beam, and I'm gonna start with the I'm gonna start with the low beam, and we're just gonna run this for just a second. Watch the resistance drop as the filament gets hot, and it should level out. I'm gonna call it 3.25, basically 3 1/4 amps for that bulb. So let's move on to the high beam, or the brighter light. I'm seeing 4.75 is what I'm gonna call that one. So now that we have those numbers, that's more realistic than 24 amps per bulb, right? Instead of 48 or 50 total, now you're looking at, I think it's, well, you could go through a calculator, but I think it's around 8, right? I think it's just about 8 amps for this single bulb with both of them running. So if you have 8 amps on this side, you have 16 with both of them, and I think a 20 amp fuse would probably do the job just fine. I've already determined that a 20 amp fuse is what we want. I just wanted to draw some of it out. Some people like seeing the math. So this is basically the circuit. We have a 12 volt battery going through a fuse, and then it will be illuminating the both lamps, which I just drew as resistors because that's how I was thinking of them. But we have the high beams and the low beams that are both connected in parallel so that they both see 12 volts. And then we measured or the current through the red and the current through the green, and those both get added together. And then we actually have 2 of these, one for the left side and right side of the car. So 4.65, maybe 4.75, around there, we measured for high beams, and then the low beams were 3.25. And then I was curious as to what the actual resistance of the filament would be when it was hot instead of cold. And if you take, Ohm's law, R is voltage divided by current, 12 volt battery divided by the 4.65 is about 2.58 ohms, and the low beams was 3.69. By the way, the red and the green, that's the color of the wire that's used. That's why I call it that. Okay, so does it make sense that the brighter light has less resistance 2.58 compared to the dimmer light at 3.69? It should, because the less resistance there is to the flow of current, the more current will flow. More current means more power, and so it'll be brighter because it has more power. So that makes sense. That's just kind of a quick, visual of some of the other factors at play here. Well, now that we know we're working with a 16 amp system, we can replace this burnt 10 amp fuse with a 20 amp fuse and be confident it's going to work. These are the low beams. Those are the high beams, and now both together. Everything's working now, and we didn't have to guess on the fuse. We can feel pretty confident about it. So hope you enjoyed the video, found it useful, and can use some of these, calculations or techniques or whatever in practical, in practice. So thanks for watching.